So far in this series, we've discussed the four fundamental forces in physics, noting the weakness of gravity, and we've covered the primary definition of a dimension. Now let's take a layman's look at string theory, which holds that the universe on the smallest scales is comprised of vibrating energetic strings. Remember the mediators of the four fundamental forces I introduced in an earlier video. According to string theory, all of these mediators are tiny vibrating strings. The gluons that hold every atom together are seen in string theory as tiny vibrating strings. Most of the force mediators are thought to exist as open loop strings, like spaghetti, with their free ends attached to our universe. Most subatomic particles that make up the structure of the world around us are open loop strings. But some strings are closed loops, like a rubber band, which allows them the freedom to go places that open loop strings can't go. Gravitons, the mediators of the force of gravity, are unique because they're considered to be closed loop strings. So they're not confined to the spatially three-dimensional universe that we know. On this slide, I clipped a couple of pictures from an episode of Dr. Brian Greene's 2003 TV documentary miniseries, The Elegant Universe, in an attempt to try to represent the difference between closed and open loop strings in string theory. Notice that the open loop strings are attached to our universe while the closed loop strings are floating freely. Most of the matter in our universe is composed of particles formed from open loop strings that are bound to our three dimensions of space. However, the unique ability of closed loop strings to float freely means that they have an increased likelihood of escaping the confines of our three dimensions of space.
Let's go back to bread. Imagine that our universe is like this slice of toast, and that you and me and all of matter, light itself, everything we see is like jelly. Now, jelly can move freely on the surface of the toast, but otherwise it's stuck. It can't leave the surface itself. But what if gravity were different? What if gravity were more like cinnamon and sugar? Now, this stuff isn't sticky at all, so it easily slides right off the surface. But why would gravity be so different from everything else that we know of in the universe? Well, it turns out that string theory, or M theory, provides an answer. It all has to do with shape. For years, we concentrated on strings that were closed loops, like rubber bands. But after M theory, we turned our attention to other kinds. Now we think that everything we see around us, like matter and light, is made of open-ended strings. And the ends of each string are tied down to our three-dimensional membrane. But closed loops of string do exist. And one kind is responsible for gravity. It's called a graviton. With closed loops, there are no loose ends to tie down, so gravitons are free to escape into the other dimensions, diluting the strength of gravity and making it seem weaker than the other forces of nature. This suggests an intriguing possibility. If we do live on a membrane, and there are parallel universes on other membranes near us, we may never see them, but perhaps we could one day feel them through gravity.
If there happens to be intelligent life on one of the membranes, then this intelligent life might be very close to us. So theoretically, and purely theoretically, we might be able to communicate with this intelligent life by exchanging strong gravity wave sources.
So, who knows, maybe someday we'll develop the technology and use gravity waves to actually communicate with other worlds.
Are you young?
Yeah, hey, it's Brian. How you doing?
Brian. Who put Ch3 jubby woofalappa jabba Simpsons.
We don't really know if parallel universes could have a real impact on us.
String theory makes certain claims upon reality that deserve our consideration. String theory predicts that our universe is comprised of 10 dimensions. There are other varieties like M theory that proposes an 11th dimension and bosonic string theory that proposes 26 dimensions. But the original 10-dimensional string theory has more proponents than these other variations and makes the most sense in light of God's creation. Since most scientists are confined to 3 extended dimensions of space along with 1 dimension of time like the rest of us, the assumption among most theoretical physicists has been that the remaining 6 dimensions must be compactified or curled up in such a way that we cannot easily detect them. Many research hours have been allotted to the study of Calabi-Yau manifolds, which is the name given to these compactified extra 6 dimensions. An artist's rendition of a Calabi-Yau manifold is on the screen, but do understand that this is an artist's attempt at portraying a 6-dimensional object on a 2-dimensional surface, so it really doesn't come anywhere close to reality. In fact, now that you've seen it, I would suggest you forget it, because such a thing doesn't exist in God's reality. The complexity of the mathematics involved in the study of these imaginary manifolds also defies the principle of Occam's razor, which suggests that if a simpler solution exists, it would be preferable. And it's my opinion that there's definitely a better and simpler solution, as we will see as we continue this video and the future videos. The idea of at least one large extra extended dimension was addressed by Dr. David Gross. He's a Nobel Prize-winning physicist at UC Santa Barbara. In his talk at the Strings 2003 conference in Japan, he said this:
"It's an exciting new idea that was unthinkable before. And that is that some of these extra dimensions that string theory requires are actually not small and curled up so that you can't ever see them, but actually quite large. And that the reason we don't observe them is that we are stuck to the 3 dimensions that we're acquainted with, that we're stuck to a so-called brain. It's as if this room is 3-dimensional. There are 3 directions, that direction, and that direction, but I'm stuck to the wall, and I can only move along the wall. And all the light rays that I see can only move along the wall. So I would only know about the wall. I would be stuck in 2 dimensions. Now, that can't be true because Einstein told us that gravity is the dynamics of space, and so if there is another dimension, the rest of the room, that's space, and the ripples in that space are gravity. So I would have a gravitational interaction with the rest of the room, but all the other strong forces of nature would just be along the wall. And gravity is very weak, and I might not have noticed the rest of the room. That's the idea of large extra dimensions, where we are stuck to 4 dimensions, 3 spatial dimensions, and so are the quarks and the gluons and the W's and the Z's and the electrons and the everything, except gravitons that can escape to the 5th dimension. Such speculations, such possibilities arise naturally in certain scenarios in string theory and seem to be totally consistent both with logic, as far as we know, and with current experiments.
Dr. Gross also captured the concept of graviton escape in his talk, As closed-loop strings, gravitons are not bound to the three dimensions we see daily, but can escape outside the bounds of our known universe. Dr. Gross mentioned the idea of brains as well. He spoke of the wall as a two-dimensional brain. The term brain, B-R-A-N-E, comes from the word membrane, which was alluded to in the Elegant Universe clip also. Technically, a membrane can be thought of like a sheet of plastic wrap you might use in your kitchen. While a membrane actually is three-dimensional, it's so thin that physicists ignore its minimal thickness and treat it as though it only has two dimensions. So a membrane can be called a two-brain. The universe we inhabit has three spatial dimensions and therefore can be called a three-brain. Brain theory arises naturally from string theory and helps physicists understand dimensions. It's helpful to recognize this distinction when we discuss a fourth extended spatial dimension. Now, we've covered a lot in this video, so let's do a quick review of the important points to remember about string theory. First, all subatomic particles are composed of vibrating strings. Second, strings are either open-looped, like spaghetti, or closed-loops, like rubber bands. Third, open-loop strings are attached to our universe, while closed-loop strings are not confined. Fourth, dimensions are either extended, large, like the ones we know, or compactified, curled up into a tiny ball. Fifth, the extension of a fourth extended spatial dimension is likely. Sixth, gravitons are closed-loop strings. They're not bound to our three-brain. They have the ability to travel along the axis of the fourth extended spatial dimension. And seventh, we'll use the term three-brain often in the coming videos when we discuss a three-dimensional universe that we're imagining as a membrane. Now, before we move on, let's consider what the Bible might have to say about what we've learned thus far. If God actually exists, in reality, He is capable of making sure His message to us says exactly what He wants it to say. That's why I've included this passage. Ephesians 3:17 through 19 says, "So that Christ may dwell in your hearts through faith, that you, being rooted and grounded in love, may have strength to comprehend with all the saints what is the breadth and length and height and depth, and to know the love of Christ that surpasses knowledge, that you may be filled with all the fullness of God." I found it interesting that the Apostle Paul was prompted by the Holy Spirit to mention 4 separate dimensions. This is likely overlooked by most people, but it stood out to me. Each of the 4 Greek words is unique, and I believe could not be fully understood until our knowledge increased to the level that we're exploring here in this series. I studied under theologian Dr. Reggie Kidd of Reformed Theological Seminary, who wrote the study notes for the book of Ephesians in the Reformation Study Bible. Dr. Kidd writes, "These measures of space recall the temple image of Ephesians 2:21. God uses the love among all the saints, Jews and Gentiles alike, to build a whole that is greater than any of its individual parts. The spatial language exalts Christ's love for His people, a love that is inclusive, inexhaustible, and self-sacrificing." Now, I certainly agree with Dr. Kidd on all these points, but I believe that in this verse, God also gives us a clue to a reality that is even greater than the individual parts we're now familiar with.